Hi, my name is Michael Kronovit, and welcome to my 15112 term project, Intellichess, which is a chess game that has fully functioning AI that uses a neural network and minimax to make moves, and sockets for multiplayer online capabilities. So let me go through the start screen real quick. You can toggle music on and off, and there are four modes. There is the tutorial mode, training mode, competitive mode, multiplayer. So first I'll take you through the tutorial. So for the tutorial, you can go through different pieces and see basically what those pieces are capable of doing through brief little animations about their movements. And then it also shows you what castling is. This will load. Okay. So now I'll take you through training mode, which is essentially a single player practice mode where you can just try out different moves and see just what are different move patterns and combinations that you want to make. So right here, I'll just check the king, and if you try to move somewhere else where you're still in check, it'll give you a little indicator to let you know you're still in check. And each time it specifies whose turn it is. So now I'll go through the multiplayer. So right now, the first player to initialize in is always the white player. So now I'll go ahead and pull up another terminal. So now this player who connects is now going to be, it says right top right corner, you are black. This player is the white player, and it is white's turn. So this player make a move. It registers on the other screen. Okay. So now I'll go through and take you through the AI and how that works for the program. So first of all, the AI uses a minimax algorithm to find the best moves that it wants to make. So that just works by, it'll go through every single possible move in the possible moves that I create, and it'll basically evaluate how the score of each move. And then after it evaluates the score of each move, it'll essentially compare that score and act as though the next human player already reacted to that score. So it simulates the next player's reaction and then updates and changes the score to match the human player's best optimal move in response to that. So for my minimax algorithm, I just programmed in that if there's some move where the AI can get a piece for free without losing any other piece of greater value, then it should go ahead and make that move. Otherwise, it uses the neural network in order to basically decide what the best move is. So in order to explain to you what I did for the neural network, I will show you right quick. So for the neural network, what I did was there are these things called PGN files. So I took a bunch of different Grandmaster games in the form of PGN files like this, and I looped through, read each file, and translated this data into some board that could be read. And I inputted this through an existing chess engine called Stockfish, which is the world's greatest chess engine currently. So the Stockfish evaluated this, or for each of these boards, Stockfish spit out some evaluation of how good that board was for each player. And then I compared that and used that as a target value for my neural network. So my neural network, it has two hidden layers. It has 64 input neurons though. So each input neuron represented a single square on the board. So basically, it would basically tell the neural network where each piece was. But when you're using a neural network, you can't really explain the rules of chess. The neural network just has to learn by itself. So yeah, so each piece that I input into the neural network had a different value. So pawns were worth 0.01 points, and rooks were worth 0.04 points, and so on, based on the value of the piece. But and then black pieces were given negative inputs, white pieces were given positive inputs. So it would compare it would basically feed forward starting from the input values for the board I give it, and it would go through all the hidden layers based on the activation function that I specify, which just converges the values to some input between -1 and 1. So basically, it would just go through all these activations and summing of the weights until it reached a final single output layer. There would only be one output neuron, which I would then compare to the target that Stockfish evaluated it as, and then back propagate through the network and train it based on the error from that target value. And that's basically how the AI works.